Hello, my name is Josh Obert, and I'm a GIS analyst with the ACPF National Hub. In this video, we're going to discuss the Riparian Function Assessment Tool. This is the fourth tool in the Riparian Assessment section of the ACPF Toolbox. This tool will determine site-specific riparian buffer designs for each riparian catchment. The designs are based on a cross-classification between two variables, the runoff delivery, which is calculated by the riparian catchment size, and the denitrification potential based on the water table depth, and that will be extracted from the height above channel output. The tool is going to run through a set of criteria within the riparian zone, which is defined as an area within 90 meters of the stream. An identity is performed between the riparian catchment and stream channel, and then a 90-meter buffer is made for each stream section. Once the buffers are generated, we assess the two variables within them, and that is the runoff delivery and the denitrification potential, to determine which riparian buffer design would be most suitable for that area. In ArcGIS Pro, we will open the catalog window in the right side of the screen if it isn't already open by clicking the catalog tab. Expand our ACPF toolbox and expand our riparian assessment section. Double-click the Riparian Function Assessment Tool to open. This tool needs 3 inputs and produces 1 result. The first input is our stream reach. Again, this will be the same stream reach that you use to generate your riparian catchments. Since it is in our map, we'll choose it from the first dropdown. This will auto-populate the other 2 inputs, our riparian catchments and the height above channel raster. Our output will be a riparian function table. Click Run to run the tool. Next, we need to assign a denitrification rank and a runoff rank before we can begin our cross-classification assessment. For the denitrification rank, we look at the low-lying land's average width within the RAP. If that average width is greater than 50 meters, we assign a rank of high. If it's between 25 and 50 meters from the stream, we assign a rank of medium. And if it's less than 25 meters from the stream, we assign a rank of low. Next, the runoff rank will be assigned to the RAPs. Areas that would convey half the surface runoff from the watershed that flows through the RAPs to the stream, considering if all areas were to generate runoff equally, would receive a rank of high. RAPs where a buffer occupying exactly 2% of the total contributing area to the RAP would be wider than 10 meters, receive a rank of medium. And a 10-meter wide or narrower buffer that provides a minimum recommended buffer area ratio of 0.02 or 2% receives a rank of low. So that 2% buffer area ratio is what's generally needed, and this is recommended by NRCS. The buffer area ratio is calculated by taking 2,500 divided by the contributing area along those bank cells within a RAP. That 2,500 is equivalent to the area of a 10-meter wide buffer along a 250-meter long RAP. And so basically, you can see down here that if the buffer area ratio is less than 2%, median runoff rank is assigned. And if it's greater than 2%, a low runoff rank is assigned. The Riparian Function Assessment Tool has finished running. We can see that the results, a Riparian Function Assessment table, has been added to our map. Right-click on the Riparian Function Assessment table in the table of contents and click Open. This table can be joined to our riparian catchments or our riparian attribute polygons by the Riparian ID field. We also have the average width of a low height above channel elevation, and that's less than 1.5 meters within the riparian zone. We have the ratio of the area of a 10-meter buffer divided by the local runoff. We have the actual runoff rank, denitrification potential rank, and then we have the suggested buffer design based on that cross-classification of those 2 fields. Then, finally, we have a suggested buffer width according to NRCS in meters, and an ACPF suggested buffer width. To symbolize the riparian function assessment, we first need to join this table to our riparian catchments feature class. To perform the join, Right-click on the Riparian Catchments feature class, go to Joins and Relates, and click Add Join to open the Add Join window. Our Riparian Catchments feature class will auto-populate as the input table, since that is the one we said Add Join on. The Function Assessment table shows as the Join table, so we will leave that as it is. For input field, we will choose Riparian ID. Since the Function Assessment table has this same field, ArcGIS Pro recognizes that the field exists, and we'll set that as the Join field. Let's hit OK at the bottom of the Add Join window. Select our Riparian catchments in the table of contents on the left and click the Symbology tab in the right panel. From the drop-down under Primary Symbology, click Unique Values. We will be visualizing on the Function field, so we will select that field from the Field drop-down. We will leave the classes as they are. For color scheme, we will select yellow, orange, brown, 5 classes. These null values are going to be the headwaters. Remember that they do not actually align a section of stream segments, so we will actually make those invisible. Click on the color box next to the null values. For the color drop-down, click on it and choose no color. Same with the outline color. If you don't have auto apply on, you'll have to click apply. Let's turn Riparian catchments on. Now at the catchment scale, we're able to see what riparian buffer design would be most suitable. For these, it's stream bank stabilization. For this, it's stiff-stemmed grasses, and so on. To recap, we ran the Riparian Function Assessment Tool and discussed how we can better show the results of the table. In the next video, we will go over the 5th tool in the Riparian Assessment section of the ACPF Toolbox by running the Denitrifying Practices tool.